Stay there, and I would like to, and actually, Henning, you're still there on stage. You're actually on the next one too. Can I invite Pamela? Can you help us lead us this panel? This next panel is, thank you, Internet of Things, smart property, metered applications, P2P and D2D transactions, automation and automatons. So with that, can I, Alan, if you can come up, Henning, already, Juan, and Peter. Just get set up here. We'll begin as soon as everyone's on stage. Yeah, this is IoT, Internet of Things. Okay, Pamela, please take us away.
Fantastic. Hello, everyone. I'm Pamela Morgan. I am the CEO of Third Key Solutions. I'm also an attorney, and I've been participating in the COALA project for quite some time now on behalf of everyone. And I'd just like to reiterate how pleased we are to be here and sharing these ideas with you. As a community, we've grown, and we're thrilled to be here. I focus on security and governance. My company implements multi-signature solutions for governance issues, and then we also work on constructing recovery plans. So we actually work on the ground implementing Bitcoin and multi-signature features. So I am absolutely thrilled to be here and talking with these guys about Internet of Things, because I think that this is absolutely relevant. And we've started the discussion today with the keynote, and then we've moved to a more technological discussion. And now we're going to move towards a more philosophical discussion. And so I'd like for each of you to take a minute and introduce yourselves, talk about the projects that you're interested in, and why you care about IoT.
I guess I'll start. My name is Juan Benet. I am the inventor of IPFS and Folkwang, two protocols. We are making the distributed permanent web. And these are two different protocols that stack on each other. IPFS is a different distribution protocol for hypermedia. So think of it like a new HTTP that changes how we move around websites, web applications, and other systems in general. This is tuned for a world that is peer-to-peer, that is distributed. We do away with the client-server model and replace it with a fabric that can move websites and web applications without origin. So you can create a payload that represents an application, sign it, even encrypt it, and ship it as just one hash. And other applications and systems can download that content, run the application locally, create new data, and add it to the file system. So this is a very new way of doing the web. The web today doesn't work that way at all. You have this client-server problem where most websites and web applications are constrained to only work across the backbone, talking from clients all the way to the backbone. This enables the web to move out of that and enable it in IoT, for example. Like you can actually ship web applications built with today's web tech directly into IoT applications, into IoT devices, and have it all work. So yeah.
I stumbled into IoT completely backwards. I mean, I really hadn't planned it. I was working with a friend in a mobile payment company, and he introduced me to Bitcoin. I was completely fascinated with the ways that Bitcoin can be scripted, and Ethereum was kind of the automatic next step there. Then working at IBM, I heard about the IoT project that they were doing based on the device democracy paper that was very revolutionized. I mean, just coming from IBM, that was very remarkable. So I started to become part of that effort within IBM, which was basically a research effort that was using Ethereum to demonstrate how a washer can go out and buy its own detergent when it realizes it's running out. And then getting more interested, it can even go out and claim that a service mechanic has to come when a sensor realizes it's necessary and prove that it still has warranty, because that's also stored on the blockchain. And then from there it gets even more exciting, where you can have a DAO, or I like this example that we should start thinking about self-driving cars that also own themselves and have a budget, and are basically robots that are freelance enterprises. So, and that's, I guess, that's my fascination, where you have this intersection of this new way to program stuff that is tied into real value that can really do business, and then has what we don't even call robots anymore, but would be something that looks different than the science fiction robots, but is actually pretty close to science fiction, and house like the full automation and the IT that goes into building a high-rise. Meanwhile, of this style here, it's just mind-boggling. Nobody imagined that some decades ago, I guess. And so that's where my fascination and my professional time with IoT comes from.
So I'm Peter Asaro. My background is in philosophy and computer science, artificial intelligence. I did a lot of work on early cybernetics and brain models and things like that. And I started to get interested more in embodied forms of intelligence and robotics, social and emotional robotics. And for the past few years, I've been looking at social and ethical implications of robotics and other kinds of autonomous systems. A lot of my time has been focused on fully autonomous weapons and trying to get a treaty at the United Nations to prohibit killer robots. So I have an NGO, the International Committee for Robot Arms Control, and we're part of the campaign to stop killer robots, which is with 9 other NGOs. The leadership of that campaign and 50 NGOs from 24 countries, and we've been working at the Convention on Certain Conventional Weapons at the UN. I also work on some civil society issues around cyber warfare, and a lot of other different aspects of the social implications of robotics. So right now I'm at Princeton's Center for IT Policy, and I just got a grant from Elon Musk to work on liability in increasingly autonomous systems. So as we move to this Internet of Things, who's responsible for the damage that is caused by some of these, semi-autonomous or autonomous systems as they go out into the world? How do we compensate those who are harmed by those kinds of systems? And that sort of aspect of the Internet of Things, as well as some privacy issues. So as these things collect lots of data, share lots of data, what happens to privacy in public space when this kind of data can be collected, archived, data mined, shared? Who owns it? What are your rights to privacy in these new contexts?
My name is Alan Shapiro. I'm a professor of industrial design. I also work in philosophy and computer science. I'm a philosopher, but I think philosophy is obsolete because it's a monodiscipline, so there's a paradox there. Internet of Things, can't say much about it from a financial or legal point of view. I would say something about it on 2 levels, one on the level of code, and the other on a sociological, cultural level of what it will mean for our lives and smart cities. My reflection on the relation between philosophy and computer science led me to my own coding project, which is I do not accept many of the basic assumptions that Alan Turing made in 1936 when he invented what we consider to be programming languages, the zeros and the ones, the logic of the discrete, the assumption that a line of code is non-ambivalent, and it's a statement of formal logic. Going back and questioning many of these assumptions, taking ideas from quantum physics, the assumption that it's cool to directly read and write data from a database. That's exactly what quantum physics says is going to corrupt the data when we get towards more systemic, holistic kinds of data. Sociologically, your keynote speech was very poetic and very beautiful. However, you used several times words like things and machines. My problem is I want to change the human subject-centered perspective of code and also of society. I liked when you mentioned self-driving, self-owning cars. I would like to give technological entities more recognition, as in science fiction. I would say, if we look at Solaris of Stanislaw Lem, which has been twice made into a film, the surprise there is that on this planet, the ocean has a kind of consciousness. So much of science fiction is about the discovery that non-human entities have, very careful to use the word consciousness, I would say recognition. The paradox there, of course, is they are objects, so I don't want to give them human subjectivity. I want to give them autonomous kind of android recognition of their own, and then we can learn from them. I think it's important, so I would speak of Internet of objects rather than things, but then that you have to move the word object to a slightly more philosophical meaning, but that's already happened in our world since we have physical objects and software objects. I believe that software should not be written by programmers, it should be written by the software objects themselves. We have to completely reverse the relationship. So I think for me, the Internet of Things is yet another opportunity to take the side of objects, to get away from a human-centered perspective, and also to get away from the physical reality-centered perspective. If we look back over the last 20 or 30 years, we've moved into virtual reality, online reality. People are, let's say, students who I teach very disoriented about that because no one has given them any set of ideas in thinking about a hybrid world. I imagine Internet of Things will lead to, say, here we are in this physical reality, but at the same time, we're in a computer game, and I could decide I want another character sitting here who would be like an animated or comic book character. I mean, we've been through, and now we have augmented reality, which is great because this is now hybrid, real and virtual. So that's my interest in Internet of Things, not too much liking the word things, not liking the word machines at all anymore, since that's the 17th century. Another problem with basic Alan Turing compliant computer science is the relation between the whole and the parts. It's like a car engine, it's combinatorial, it should be relations of similarity or of resemblance and dissonance between the whole and the parts. It should be a holistic relation, as in fractals or holograms, and it's been theorized in some books on holistic biology. So I would like to just really bring the humanities into informatics and then rethink the whole thing.
Thank you. Playing along that line, I think that it's really important that we look at social and ethical implications, and so I'm going to direct this question to Peter. You mentioned that in your opening talk, and I'd like to hear more about where you think that we should focus. When we look at societal and ethical implications, where should we be focusing? Those are broad subjects.
Yeah, well, I mean, on the one hand, there's these sort of larger questions of the Bitcoin currency and the sort of regulation and the social implications and economic implications on the large scale. But I think in the context of the Internet of Things, we can think about, I guess what appeals to me about this whole notion of the blockchain, when you kind of boil it down, is that it's a distributed database system that sort of allows itself to compute itself, so you don't need the centralized computation. And it can be tied to a currency, but it's not necessary. And the kinds of currency it can be tied to are artificial. So you don't necessarily have to have an exchange to a real currency. And what that lets you do is create artificial economies. And so now you can apply all the metaphorical thinking about economies to these artificial economies. And you can do lots of interesting things with that. So then you can do bad things with that. So here's the bad stuff. I'll start with the bad stuff, and then I'll tell you the good stuff. Bad stuff is like, okay, your coffee machine is like tied in the Internet of Things, and it's going to start charging you for your coffee in the morning based on the price of coffee today, and how tired you are, and how badly you need to get up to work, and you're going to get surge pricing on this, or maybe your washing machine knows you're almost out of underwear, and it's going to surge price your underwear, and like you really don't want that, right? That's a terrible world to live in. And then you have the drone example or the self-driving car example, which I think is really useful of negotiation, right? So it's hard to think of a really good protocol for negotiation in the abstract, but we negotiate economic contracts all the time, and we can allow those sort of methods of economies and markets to drive negotiation. So if we need to negotiate lane change and letting somebody into a lane between self-driving cars, that would be a way to do that we can sort of exploit the sort of natural property of an economic system to achieve a practical goal. Again, the bad thing would be to actually tie that to a real currency, to where people can hog the lane until you pay them enough to get out of the way, right? And so you wind up with all this rent-seeking behavior and people who are trying to exploit each other through all these creating inefficiencies artificially, basically. So the positive side is, well, where can you create efficiencies? And I think this is kind of really interesting, and probably a few miles north of here is where it's really going to find its main application. So if you want to make an efficient factory, right now you have a lot of overhead in accounting and administration. So for the 1920s to the 1980s, we had all sorts of operations research. How do we optimize the efficient production of manufacturing systems? Starting in the 1980s, we started thinking about, just-in-time production, flexible manufacturing. How can we reduce inventory, increase the flexibility of our production to supply chain changes and things like that? And that gave us like an order of magnitude, greater level of efficiency making over previous kinds of operations research. Now we start thinking, hey, we can actually tie the accounting of the efficiency of a particular system to that system. So every robot becomes a consumer or a economic agent in the factory system, which isn't necessarily tied to other systems, but this is now a system that automatically calculates its own efficiency. So you can keep track of it based on, well, these robots are producing more than those robots. As we lose robots for maintenance, we don't have to readjust our model or change our data analysis models or anything like that. It's all built into the system. And so we get out as a sort of side effect of the creation of these systems, whole new ways of optimizing efficiency in this manufacturing systems, for instance. But that could be applied to all kinds of different systems.
Anyone else have anything to add? No?
I think that as we go into understanding how to bound the behavior of these, what are going to be pretty much autonomous agents that are not actually intelligent, right? Like what we're going to have is not strong AI that is capable of reasoning. We're going to have a very, very dumb set of optimizers. And this is actually one of the riskiest things to have. This is the paperclip machine. So like if you're familiar at all with AI theory, kind of like the more recent castings of how we get to strong AI and what problems there are. One important avenue of this research is into non-strong AI agents that are merely optimizing some function. And the moment that you have a storage fabric across the web, which is kind of like what we're building, and the moment that you have a computing fabric across the internet, which is what Ethereum and Bitcoin and so on are building to some extent, and the moment that you have a way to give them resources and access to any resource, meaning they have some currency and they can get more currency and so on. The moment you write a function that is capable of economically doing something valuable enough for the rest of the network, or clever enough in respect to the rest of the network, to start accumulating money, and is able to pay for its own computing, and is able to pay for its own bandwidth and so on, you have a thing that can pretty much grow unboundedly. At first, these optimizers aren't going to really do much. They're just going to accumulate wealth for some set of parties. But the tricky question comes in when, what happens when a driverless car that owns itself has to decide whether or not it should ram into the other car and bring down the supply of driverless cars so that it makes more money. These things are going to be very real. Because unless we place some strong bounds on this technology. We're gonna deal with, see, it's autonomous agent already. So it's, right now I think like important amount of work needs to be done in trying to understand how these optimizers will behave and how might we place some amount of simple reasoning about trade-offs. I.e., how can you make ethics mathematical in a way that we can embed into the programming? This is something that almost nobody in any kind of distributed computing research, or almost nobody in like the blockchain cryptocurrency world is thinking at all about. We're just kind of making cool stuff and making more of it and making optimizers. And this is like, it may be important to take a step back and think about these agents and what they're going to do, and think about clearly how to write these libraries and so on, so that somebody doesn't accidentally cause a total disaster.
I don't agree with what you said, that these are going to be autonomous agents that are not intelligent. Although you did modify a little bit your statement.
Not strong,
went
strong AI.
Went on.
Not strong AI.
But I think that to take the example of the self-driving car, it's a platform. It will be a platform. And as soon as you have a new exciting platform, you have a whole world of people, of programmers and developers and entrepreneurs adding onto it. And just as with the smartphone as a platform, you have a world of apps, of all kinds of exciting stuff that comes onto it. When you have self-driving cars, one of the main benefits is reduced accidents because the human error is gone, but then it might become very boring and dull because you take a lot of the thrill out of driving. So then people will write using the API of that platform. They will write further enhancements to what the self-driving car can do. And it will also be a virtual reality entertainment game platform. So I think analogously we could say about distributed ledgers like the blockchain. I think it's a platform, and now we're just at the early stages of negotiating, competing, what that platform is going to be. But the real excitement is all the applications of it, I think. So I don't see why it needs to be restricted, or we should focus on a dystopian fear of intelligent agents getting out of hand. I think it's
one aspect I would like
excitement of it.
to add is that the blockchain is going to be a vehicle to allow devices to police each other, because a device is basically kicked out of the consensus and the other devices will not deal with it anymore, or even shut it off of any kind of market when it is a root device and doesn't follow certain rules. And of course we will have more interesting rules in the future that are part of the consensus mechanism.
The concern is that gap. The concern is the gap between creating the simple optimizers of today, like the poker bot that's gonna like make more money, or the self-driving car that will pick up fares and so on, and the gap between that and creating a true machine consensus that is able to understand ethics and be like analyze what the system is doing in a self-referential way. I think like that is a level of intelligence that is not what we are currently building. That is, we will end up building something like that. But what we're currently building is just like basic agents with some basic algorithmic capabilities. Some of the more interesting things that we'll start So you mentioned self-modifying code, and that's one of the things that I'm really excited about. The moment you have self-modifying code, what can happen? Turns out like pretty dangerous stuff, right? Like this is interesting, but it's like fire. You have to play with it carefully. So a friend of mine made a bot called Bot Will Accept Anything, and this was a riff on another program before, which somebody made a GitHub repository, and he said, I'll merge any pull request you give me. And so kind of saw where it went. So anybody can contribute code, and he would just add it in. Some code broke the build, some code will just add more stuff and fix it and so on. So my friend said, great, let's just make a bot that does this and just pulls people. And so there's this repository right now on GitHub where you go to, and if you submit any pull request with code, it will run a poll. And it has a threshold of votes. And the number of that many votes vote yes, it'll merge code. This could do anything, right? Like you could go and take, probably shouldn't tell you to do it. You could take Stuxnet and like add it in, and then this thing will be replicated everywhere very quickly. You could give it the ability to make Bitcoin transactions, and it will now have the capacity of buying things. This kind of stuff is like an interesting experiment that could easily like cause quite a bit of damage accidentally, right? And so like, yes, we can find a way to make all of this stuff better, and of course, if we think hard about it, we will, and we'll make machines that can have like this more intelligent behavior. However, the gap between now and there needs to be treaded carefully, and what we should be thinking about right now is as we deploy these agents into these systems, what kind of ethical rules must we include? My point is not that this is impossible, rather that we're not actually doing it. Like when you look at the people that are actually building this stuff, I'm one of them, we're not actually using these libraries of like, oh, think reasonably, will my agent care about other agents? No, actually, this agent just wants to make more currency for itself, right? And so like that's an important thing that we should be thinking about before we deploy massive computational systems that allow any optimizer to do anything.
But I mean, it's not quite true that there's no discussion about it. I mean, we are joking about that Ethereum is Skynet. Like that's the improvement of Ethereum over Bitcoin. It's Turing complete. It can't be stopped, in our fantasies at least. And I think that's the qualitative difference there, that if you deploy a application to the blockchain, then you basically give up control. While in the past, you always could shut down the computer, at least. So the quality of the mischief that you can do, I mean, spreading Stuxnet or whatever you want, you could do that before, and you could do that without blockchain, or you don't have to have Ethereum for it. But I agree, the thinking of what the consequences could be of even benign projects that are not assassination contracts or whatever, which I don't know if they exist or not, or just a myth, but something that we're talking about. But the gap between these extreme examples and the stuff that could actually happen as a side effect from benign projects, that's something that's not been tested.
It's incredible how much damage I can do by clicking the submit button on my computer screen. I could click OK and spend 10,000 US dollars out of my bank account, which is in most cases irrevocable, just because I would maybe even brush into the mouse in a slightly wrong way and it would click. Or I could write an email and destroy a friendship by with a few poorly chosen words that I forgot that I expressed in anger and then forgot to remove from the email. And if I make the mistake of clicking OK before I do that edit, I could destroy the friendship. But so we've created a world already online where we are surrounded, fraught with dangers of destructive action. So I think that's already, I mean, of course you're right, absolutely right. Ethics, extremely important. Fear and worry, extremely important. But I would say, let's think about how fucking destructive the world we're already living in is, right? And instead of projecting apocalyptic fantasies into a future, which may be just psychological projections of the huge mess that we are already in.
But what you're describing as so destructive is basically a testament to the power that it has. And of course you can use it destructively, but you seem to wish to have the one without the other.
Yeah, I think
I think it's our responsibility to use these technologies carefully. I agree. It's very, very powerful.
Yeah, I think they're very powerful, and I'm all for building ethics, and I'm a little more skeptical about how you build that in with blockchains as a particular technology. There's other ways to do it that, again, don't require blockchain. But I think also there's, something about this idea of sort of financializing all kinds of other transactions, right? That is sort of a broader social phenomenon that is enabled through this technology, right? So maybe we don't want all of our interactions and negotiations to be financialized, and that in itself is sort of a bad way at approaching the world and affects human relationships in other ways, and we should discuss that and think about how we can negotiate those in different ways. But I think there's also a function, as that increasingly happens, the volatility of change is also, I think, much more dramatic, and I think that's a kind of economic phenomenon. And whether these blockchain sort of systems are able to actually stabilize over time, or are they going to create increasing volatility over time as more and more sort of transactions. So it's great to have 24-hour stock market exchanges or whatever, sure, but and having 3 microsecond contract settlement, but is that going to actually increase financial stability, or is that going to increase financial volatility over time?
I'm going to move to a bit more practical question here. When we look at these systems that are using optimizing, I can't help but think about data collection and privacy issues, and how overall how are these agents, how are they collecting data? Who owns it? How are we storing it? How is it accessed? What's happening in the development world today, and what should we be looking at?
Yeah, I mean, obviously the state of affairs that we have now is that our mobile phones are basically owned by the manufacturers of the individual brands. And we've gotten used to it, more used than I thought it would happen. But I think this is going to be a strong roadblock in the future of the Internet of Things, because people will not tolerate their toaster spying on them, or advertisement burned in their toast just to have a free toaster or whatever. It's not going to be a business model. And also, the more data that is being collected by endpoints, the less value will it have, because you can only target so much advertising from it. And when all Internet of Things just use as a business model to collect data, then the data's value is going to go down. However, I mean, the beauty of this adapt concept of the democracy of things was the approach to try to assign the ownership of the devices to the actual owners, or even the devices themselves, and have a government through that cuts out this central governing authorities or company, and instead has the blockchain as the medium where you could have devices that are negotiating out of their own agency with each other instead of being centrally controlled. And this was the case I tried to make in the keynote, that this has a lot of overhead, and on the other hand, it's exactly where blockchain makes so much sense for IoT.
I would just sort of somewhat disagree, and to that extent that, so I guess the current sort of surveillance of personal information through smartphones is very powerful, because you carry it around, you can put so much kind of personal information in there, and you're giving a pretty exclusive access to the app people that you've agreed to let have access to it, or the cell phone manufacturer, or your telecom provider. But once you move into this Internet of Things, you're actually giving them all kinds of additional information about how you conduct practices in your house and private spaces and interpersonal relationships that goes beyond just your geographic location and your search behaviors and your network of telephone number friends and things like that. So there's a whole set of new information there. But there's also a whole new set of ways to influence your behavior. So showing you an ad is one way of influencing your behavior. But if you have a self-driving car and the car knows now from your personal information that you have a weakness for donuts, it's going to drive you by the Dunkin' Donuts at every opportunity. It's going to be making route changes based on this, or also maybe making slower deliveries in order to make sure that you get hungrier before you get there, so you stop for a snack, right? And who has control over that information? And your
very
personal
tempting to program that to say.
And your floor cleaning robot is going to say, oh, you spilled some wine, you better use this product to clean it up. And is that because that's the best product to clean it up, or is that a paid advertisement from the cleaning company that manufactures that product, right? And suddenly you don't have access to the source of the information that these devices are providing you, and how much that has been controlled and influenced by personal data that it's gathered about you and who that's been shared with, and a whole host of additional problems.
That's all interesting. Another set of concerns here that we have to think about with IoT is the moment that you have a whole bunch of devices everywhere, and this could be from the wearables to the things in your house to things deployed out, kind of connecting all sort of like parking meters and so on. We have to deal with I think, three main technical problems. Like, one of them is connectivity. How do you connect all of these pieces together? That's pretty straightforward. We know how wireless works. Conceivably, we can solve this pretty quickly. But the second is security. Once you connect all of these pieces, how do you deal with attackers getting into them? If they can execute arbitrary code, how do you protect this? How do you do updates securely? All sorts of exploits exist for our main computing devices. The moment that we hit IoT and we have to deal with attacks on personal devices across our homes or infrastructure devices in cities, that gets hairier. And it's already pretty hairy. Things are not as safe as we would like them to be. And they can get better. We just need to focus on that for a while. I think security is a big deal. The third is a distributed consensus that is regional or localized. And I think this is where I depart a little bit from the traditional notion of what a blockchain is. Most blockchains that we have now are these consensus systems that are completely global, and you have this round-based protocol that sort of ticks. And with every tick, everyone has to be connected, and everyone has to be online at the same time. When you look at the real network and you think of where all of these IoT devices are going to be deployed, that's not actually completely connected to the internet all the time. In fact, if you go away from kind of the developed world and developed cities, and you encounter like rural areas or even places in developed cities that just are kind of not very well located, you find all sorts of connectivity problems, even today. I mean, I just took a really long trip throughout Europe, and I was surprised to see that even in Germany, of all places, kind of between cities, connectivity dropped to be pretty bad with like wireless devices. And the latency got so big that major websites would just not work anymore because the timeouts were just breaking. And so we live under the myth that says that everything is going to be connected completely right now or immediately. And that's not actually perfectly true. We are on that road, and we are heading towards that, but it's slower than we expected. So we have to design these systems, these consensus systems, and these exchange systems to work in a distributed case where they cannot reach each other across the network. The good news is that there are such consensus protocols. You can make them, and we can build them. And I think one of the most interesting areas of research for consensus in general, blockchains, and these market protocols. At Protocol Labs, that's our company, we call them like market protocols, is where you have like this regional consensus where it's not necessarily a geographic region, but you have a sort of hierarchical construction where you have sets of nodes that can decide things with each other, and like these consensus groups will decide things that go all the way up. So for example, if the backbone of the internet, or if we get disconnected from the backbone of the internet and I want to send you money and you're in the same room, I should be able to do that. There are ways of achieving this, just not with the current way that blockchains are structured and not the way the current systems are designed. But that's, I think, one of the most interesting areas that I think we'll solve over the next year and a half.
I think that cryptography is extremely important, and security, as you mentioned. I think we have the opportunity with Internet of Things to build security into the design. It's absolutely essential. We didn't do that in the 1990s when we invented the Internet, that there wasn't thought in the design, in the security. You can even, with Internet of Things, you can have your body hacked into. One of the, I think, earliest applications is going to be in the medical area, that when you get like heart valves after medical operations, you get devices installed in your body. They're going to, in order for doctors to monitor what's going on in your body, these objects will be interfaceable and interface addressable. So there can be, someone can hack in to your medical implants and kill you. On the other side, we have to think about the negative power of software in general in our world. I think, since you mentioned Germany, the scandal of Volkswagen, of using software to trick the American Environmental Protection Agency, going into a mode of low toxic emissions when the software detects that an EPA test is running. My interpretation of that is somewhat that morality, ethics, goes into a gray zone, goes into a nebulous zone. The awareness of ethics is somewhat diminished by the fascination of software, that those engineers and managers at Volkswagen who thought that was okay to do, they were seduced to say, if we can do that with a neat trick of software, then that's a pretty okay thing to do. And even losing
that's
track.
not how those things happen, right? That's not how those things happen. That was desperation, I guess. And they reduce emission, and that's maybe a German focus, to reduce CO2 instead of NOx.
But I think the lesson is that we need transparency on how these algorithms work, right? And without that, we don't have these assurances. I think that's what's amazing about blockchain, right? That it allows you to get established trust, but allowing certain things to be non-transparent and certain things to be transparent. I don't know how to apply that to a case like Volkswagen, but if we could, that would be great. Like, how do I verify all of the algorithms that are embedded in all the chips in my car, in my robot, my drone, in my airplane, whatever? I think that's a big problem, and if this technology can apply to that, that would be incredibly useful.
I mean, interestingly, the Internet of Things is at this interface between hardware and software. And the hardware world knows so much harder requirements when developing systems. Like, they have to prove every step of the way. They have to verify the attributes that you built into a chip before you build the chip. And I think we will see a spillover from this kind of discipline that you see in hardware to software to go towards what you're just requiring.
Thank you so much. Do we have time for questions?
Yes, we do, from the floor. So do we have takers? We have one at the back. Has anyone heard of the book by Pascal called The Black Box Society? No, you should read that. First question.
Thank you, Panda. Hugh again. My question's for Peter. A couple of interesting things coming out of this. I have to say I dislike the term Internet of Things because it assumes that software and the virtual world is not reality, and actually I disagree with that completely. It's already reality, and we already have the Internet of Things. Putting that complaint aside, it seems clear that the Internet of Things discussion very quickly went to artificial intelligence. And in artificial intelligence, I've got very dated knowledge, which is why I'd like Peter to educate us a little. Used to be that you used neural networks and you needed an incentive system to train your neural networks. So my first question, is blockchain and Bitcoin relevant, and has there been some academic research into that topic? And the other one is the way that the consensus system works is top-down rules. The developers, the community, they put rules into the software, and then everything runs with the same consensus and democracy, and they reach consensus. It sounds very much like Isaac Asimov's 3 rules. So these are these 2 possible intersections, in fact, between blockchain technology and artificial intelligence. And have any of those been studied, or is there any merit in those thoughts, Peter?
I'm not aware, and I'm not really up to date, I guess, on the literature at the intersection of AI and blockchain per se. I think what's really hot in AI right now is deep learning. And deep learning sort of goes beyond the more traditional inductive statistical learning algorithms like neural networks to add unsupervised learning stage at the beginning. So, which is basically clustering similar things together and then doing inductive learning over that. So what this lets you do is you use large data sets. So like Google can take their whole database of Google images as they find them on the internet and then learn to recognize a cat photo based on labels, because we've all thankfully labeled cat photos for them. So they have these vast data sets now. And this is where a lot of, I think, the advantages over the last decade in AI have sort of come from, being able to exploit big data using some of these techniques. But they're not, I don't think, sort of orders of magnitude of sort of leaps forward in AI quite yet. And we don't really know like what the breakthrough in AI is going to be that's going to sort of lead us to some super intelligence or human level intelligence. At the other hand, like being able to process vast amounts of data and do that kind of inductive learning has applications and power, right? That greatly exceeds human intellectual power in certain specific ways, right? And finding useful applications of that is always going to be challenging. Whether you can apply some of that to these things, I mean, what you might have is something like applying genetic algorithm technology to figure out what good sets of rules or what sorts of, establishing contracts or initiating a blockchain or something that would be more successful or provide more reliability or be more stable over time, or whatever your sort of criteria are.
I feel that, interestingly, the discussions about the potential dangers of the Internet of Things and optimizing algorithms creates a pressure on formalizing ethics and higher values into code that we didn't have before. Until now, it was always a great thought to have a self-aware AI or a machine that can make judgments that we recognize as value-driven. But now, all of a sudden, we are facing a future, or a near future, where we will have an actual application for that. And I'm very curious to see how that will push the whole domain into new fields.
I think we have one more question. Sorry. Go ahead.
So one interesting area of research is called promise theory. And this is around understanding how agents might cooperate and what kind of rules and bounds and understanding can you have between these agents before they start acting on each other. I think you probably won't yet find direct research on how agents on the blockchain operate yet, because most of the research on optimizers is just generalized. It's talking about optimizers that have access to resources. It directly applies. It's just not a special case to blockchains. Another interesting kind of limit that we have, which is useful for us right now, is that blockchains don't do a lot of computation, right? If you do a computation on a blockchain, we're talking about bounding that computation with on all the nodes. The moment that we build agents which can spin out computation off-chain individually, and you have like a small piece of control on executed as a smart contract, guiding a whole bunch of other computation that happens outside. So we're talking about maybe running neural networks outside and then taking the output of that as a decision. That's when we started getting into some interesting intersections between current AI agents, or current AI learning systems, and blockchain things. And that might be a viable area to do some work in.
One last question.
Hi, a data point and then well, a couple data points and a question. One data point, you talked about the paperclip problem. In Second Life about 10 years ago, the gray goo problem actually happened, where basically things copied, and their only way of shutting it down was to actually literally shut it down. So in that case, thank God they had a server. But it poses a risk here, because if you have a paperclip or gray goo problem on Ethereum, you might try to shut it down, but then what, right? So it's actually potentially urgent, which leads me to my second part. And that is, so I did a PhD in AI applied to artificial creativity, and using genetic programming, actually, which is self-writing code. And this sort of technology, a lot of people have done stuff related to this. You could have these sorts of things running in Ethereum or sort of related to Ethereum and getting paid in Ether, and you could be putting those on the blockchain tomorrow. They could be creating value, being their own DAOs, et cetera. And as they, they're going to be incentivized to get better and better at it. People could be uploading code in GitHub, et cetera. So this stuff could happen, with off-the-shelf technology today, right? So this is, like, in my view, very, very urgent, and therefore I think the ethics of it is urgent too. And my question is, you've talked about ethics is important. Could you speculate on what this might look like to imbue ethics into Skynet?
Well, I'm going to push the humanist track here, which is that first and foremost, it's the humans that have the morality, right? And we don't want to forget that too easily. And there may be bad actors out there, and we need to think about how to deal with that. But I think what we want to do is figure out what are the social goals that we're trying to achieve, and then figure out, are there technical means of enforcing that at a sort of low level within a platform or within an architecture or a policy or a specific system. And then you're sort of thinking about the application. And as you get to finer grain, it's more and more specific. But ultimately, we have to keep in mind that these things are still being created by people, and anything that might become sort of fully autonomous on its own is something we should be sort of intrinsically skeptical about and have certain kinds of safeguards in place for in general, just because we don't know what it might do. And I'll probably talk about that more in the philosophy panel.
So
Yeah, I think that
I would say that in the end, of course, people can shut off all the Bitcoin or the Ethereum network. So there's always that safeguard. It's not that Skynet-y, what we have here now. So, and that kind of takes a lot of catastrophic pressure from the whole scenario. At the same point, my expectation from AI is relatively low. I believe that we will, for that, also not too soon encounter a artificial intelligence that is kind of deceiving and plays tricks, trying to escape persecution by people or whatever. It's going to be algorithms, yes, optimizing algorithms are also already now, bots are bringing down exchanges as unintended side effects of something that was originally a benign, positive goal of security. And still the means that we will have to use to attack these challenges are going to be very, very modest. It's just going to be writing code, and it's going to be statistical and mathematical, and using foresight and understanding implications, not something that actually really deals with an alien intelligence that tries to be smarter than us.
I think that in knowledge-based systems, we've been thinking about this either-or choice between a human or a software autonomous agent. I think we should try to move towards hybrid systems in which the autonomous agent plays a certain role in the system and has a useful place in it, and there can also be a human ethical judgment who's involved in that. So I would say, if I was to design the museum of the future in the cultural area, museum of the future, library of the future, knowledge bases, AI question and answer of the future, there can be both an intelligent agent component and then a human ethical agent who's involved with it as well. Ethics is itself a minefield. I mean, ethics is philosophy and theology and religion and atheism. I mean, we need more education, we need more focus on ethics itself. It's an intercultural, planetary question. It's not just about right or wrong, dangers of excess. We have to communicate with each other and even agree on what a system of ethics is, coming from so many different traditions.
I would just add that too, like, you want to avoid designing systems that allow people to avoid their responsibility, right, and duck out of it and escape liability and things like that.
Okay, quickly in 30 seconds, because we gotta end this. Number one, I think the first thing to do is to keep human safeguards. So we have this with Bitcoin today. If there's a fork or something goes wrong, people roll back the chain and pick the right fork and go on. As we build out these systems, we need to keep that in place. Of course, you don't want that to also be a route for economic, you don't want to incentivize people to use that as an economic gain, but we have to have that in place. Two is spending more energy in research along these areas to understand how we can do monitoring of these agents and what they're doing, where the money is going. The more that these things are transparent, the better. This includes perhaps not building completely homomorphic encryption-based systems. We're going to go in that direction, and the moment that you have smart contracts executing that you cannot read at all, that's a problem. Three is exercise a lot of caution when adding any kind of intelligence system, and look at what there are these research areas that are coming up with good sets of rules around what to put in a program that might have access to resources and can self-replicate and all that kind of stuff. Look at those rules and think about them. And if you want to do a really cutting edge thing, then just go into researching promise theory and so on to find the real answer to the optimizer problem. There may be one. It hasn't been proved wrong. So good luck.
Thank you.
So with that, could you please put it together? I mean, perhaps Memristor-powered ethics bots might be one of your first apps. Okay, could you please give this panel a big round of applause for a most inspiring. We have now a coffee break of 30 minutes. Please.